Hi all, welcome back to this session, another session. So in the last session we discussed about inheritance, also we discussed about aggregation as well as composition, and we studied about how to write method signatures or how compiler while resolving method calls uses method signatures. So we saw how method signatures are defined. So in this session we'll move forward with the most OOPS concept, that is overloading. So we'll study in detail about overloading. So let's quickly jump to our document. So what is overloading? So two methods are said to be overloaded if and only if both the methods have same name but different argument types. Okay. So the method name should be same, but the argument types that we write int, float, or something, you remember, like these are the argument types. The method name should be same, but the argument types should be different. Although here it's same, but it should be different. So that is what this overloading, this definition is trying to convey to us. So next point is that in C language, method overloading concept is not available. So we have to declare multiple methods with the same name but different argument types. Okay, so we can't declare, sorry, with the same name. So we'll have to, in C language we'll have to give every method a unique name so that it can be cleverly recognized by the compiler. So in Java this is not the scene. So in Java we can declare multiple methods with the same name but different argument types, and such methods are called overloaded methods. Okay, like example, absolute method, we all know absolute. Inside absolute method we can pass the value as int I also, abs of long also, and float also. But in C, what's the different, that we have to, like, absolute of int is something like this, written as abs of int of I. Okay, but absolute of a long value should be written as labs. The method name should be different, but the argument types will always, the gist is that the argument type should is always different in overloaded methods. Then comes the picture of float. So again in C you will have to give the name as unique. Argument is up to yours. Okay, but in Java where this can be done achieved using a single method name as well, and the argument types will be different, and such methods are called overloaded methods. Okay, so having overloading method in concept reduces the complexity of programming. Okay, so let's see how. So let's see, we have a class test. We have public void m1 with, that has a print statement of no args. Then we have public void m1 int of I. Okay, that has a printing statement int arguments. Then public void m1 double d sopln system dot out dot println double arg. Okay, so you can see from this picture itself we have the same method with the same name but different argument type. This has a null, this has no argument, this has int argument, this has double argument. Okay, so let's see in the test class, let's see what inside the main method we'll be creating the object test t is equal to new test. I'm creating object of this class, and these are overloaded methods. Okay, so if I call t dot m1, so what will be written? T dot m1 of nothing, so no arg method will be called. If I call t dot m1 of 10, int arg method will be called. If I call t dot m1 of 10.5, then double arg will be printed. Why? Because t dot m1 of nothing is about this method. Then we have one overloaded method for int argument as well, and we have another overloaded method of double argument as well. So this, I hope this is, there's no something special about this. This is clear that the method name should be same and the argument type will be different. That is what is called an overloaded method, and that is the simple fact of overloading in Java, that method names are same but different argument types. Okay, the gist is that method name will be same, different argument types. So let's see few conclusions around overloading in Java. So in overloading, method resolution takes care by compiler based on reference type. So this t is the reference type to this test class. Okay, and hence overloading is always considered as compile time polymorphism or static polymorphism or early binding, we can say. Method resolution in the sense means which method has to execute. Okay, so which method has to execute will always depend on the reference type. Okay, so yeah, reference type. So this method is being called with reference to this t object, that is of class type that is of type test. So this method resolution is always taken care by the this T object. Okay, reference type. This reference type is of this M1 is T. Correct. So this should be taken care in in method overloading. The method resolutions take care. It is taken care by the compiler using the based on the reference type. But in overloading, we'll see that it is based on the runtime object. Okay, so runtime object is this one. Correct. And this is the test. This is the type of this, and this is the new keyword. Okay. So let's see few loopholes in overloading. Automatic type promotion in overloading. So let's understand what is this. So while resolving method, if overloaded method, if the matched method is not available, then we won't get any compile time error. Okay, compile time error immediately. First it will promote the argument to the next level, and then it will check whether the matched method is available or not. If the matched method is, so what does that mean? While resolving the overloaded method, so the compiler will always check for the, that won't compile immediately. It will check for the whether there is a further more enhancement for the promotion for that argument or not. So I will see the promotion. This is what possible promotions in overloading are. So if the matched method is, let's say, available, let's say you call abs of 10. Let's say if abs of int I is defined in the class, then it's well and good. If it is not defined, then it will automatically proceed for the next promotion argument. That is in, let's say it will see whether it long is there or float is there or double is there or not. Okay, if once again, if the matched method is not available, then compiler promotes the argument once again to the next level. This process continues until a possible promotion is matched. If it is still not matched, then it will throw a compile time error. So what are the possible promotion combinations here? So if let's say you have a method with it's something like that, byte can be promoted to short, then short can be promoted to int, the int can be promoted to long, and then long can be promoted to float, and float can be promoted to double, and same as here as well, that char can be promoted to int. So this is the possible promotion cycle, we can say. Okay, byte to short, short to int to long, float to double, and then char to int. Okay, so this is how, if int is not present, it will check for if long is present or not. If long is not present, it will check if float is present or not. If float is not present, it will check double is present or not. If double is also, if neither of these are present, then what it will be, it will throw an compile time error. Okay, this is the process of automatic type promotion in overloading. Let's see an example for this. So we have a class test public void m1 int of I, and then the print statement is int argument, and public void m1 float of I, float of argument, that is the print statement. So let's quickly okay, so what we have done here, we are, as we know, we are creating an object of this test class. Test t is equal to new test, and then t dot m1 of 10. So m1 of 10, can you guess what will the output? The output will be int argument. Why? We have an int argument type method m1. If so, compiler will always look for what? Method signature. What is the method signature? M1 of int. Okay, so we have an int, so it will give you the output as 10. Then we have t dot m1 of 10 point f float, so we'll get an output of float. That is pretty straightforward. Then t dot m1 of a. So why a will print int argument? Because it will search for a, that is character. M1 of char is not present, then it will, what it will do, it will promote this char to int type. Okay, so see, it will promote this char to int type, and since int is present here, int argument method is present here, so it will print out int arg. That is what type promotion here is. Okay, if you type long, and there is no such method that has an argument type of long, but it will automatically be promoted to float. Since after long we have a position, for float, we'll see for float. And let's say we have 10.5, that is double. Correct. So 10.5 is a double state, so it will say that it cannot find anything, cannot find the symbol, the method name, and the location class test. Why? Because after double there is nothing present, and there is no promotion possible here, since we are already in the backward approach, in the backward direction of the hierarchy. That is, after double there is no promotion. Okay, so this will give an compile time error. I hope this is clear. Simple. I'll repeat again. 10, why this is 10? Since we have a method with the same argument type, that is int. 10.5 f float argument, because we have the m1 of float of m1 with the float I of argument. Then a, why? Because this also, because character is not present, so it will promote this to int, and int is present, that we have a method with the same signature, that is m1 of int, so this will give you int arg. Then m1 of 10l, this is float, because float is not present, sorry, long is not present in the method table, we can say, call stack. So this will promote this to float. Float is a method that is present, so what will be done? So this will print you float arg. Okay, so let's move on to the case 2. So what is case 2? Class test public void m1 string s, sopln string version object public void m1, that is of object type, object version is the output, sorry, is the print statement. So we inside the main method test t is equal to new test, again creator the object of this test class. So t dot m1 of new object. So this is basically a new object, in the sense we are passing an object here. Okay, just for reference I'm telling, new object, we are passing an object. So t dot m1 of object, what will print? It will print you object version. Then t dot m1 of Durga, what this will print? This, since Durga is a string, so this will print you Durga string version. Okay, then t dot m1 of null. So null is what type? We can say null can be any type. It is also defined in string, as well as it is also defined in object class as well. Correct. So what is the why we have got string version here? So we have got string version here because while resolving overloaded method, compiler will always give preference to the child type argument. Okay, when child is not found, then only parent will come into picture. Okay, so since null belongs to both of these, object can be also be a null, and string can also be a null. So while resolving the method, the compiler will give first precedence to the string. It will see that there is, it will first of all see that m1 of object is there and m1 of string is there. It knows that string is the child class of the object class, so it will give precedence to the string version. That is what the gist here is, that always while resolving overloaded method, compiler will give precedence to the child type argument when compared with the parent type. If child is not present, then in that case it will give you the parent execution, or the whatever the logic you build. Okay, so let's see the case 3. Case 3, when let's say we have a sibling, as we know string, we have public void m1 of string argument, public void m1 of string buffer argument. So string buffer and string both are what, siblings to each other. They belong to the same hierarchy, correct? And the root is object. Okay, so let's say test t is equal to new test t dot m1 of Durga. Definitely it will give you string version. Then test t is equal to, we will create a string buffer object and then we'll pass the string, so this will give you the string buffer version. But once you pass string t dot m1 of null, so null belongs to both these of version, that is string buffer and string. So what will this will say? This will say the reference is ambiguous because both belong to the same hierarchy. String and string buffer both belong to same hierarchy. There is no parent child combination here, correct? So this will get confused to which method I should execute. So this is ambiguous in nature. So this is something that will give you a compile time error saying that reference to m1 is ambiguous. Simple as that. So since there is no parent child here hierarchy available here, so this will give you a ambiguous issue. Okay, so next comes into the picture the case. I hope this was clear. So next comes into the picture, let's see for where args, I think so. No, so class test int of I and float f, int float version, public void m1, float f and int ih. Okay, so sopln float and int version. So public void, public static void main, again main method. So 10 t dot m1 of 10 comma 10 point f. So what will this will print? 10 comma 10.5 f will print int float version. Why? Because we have int and float combination here. Then this will print t dot m1 of 10.5 f comma 10 float int version. This matches the exact scenario. So now what is this? What will, why this will give an ambiguous issue? Just think about it. So why it will give an ambiguous issue? We have seen the case. So let me tell you quickly. This is 10 comma 10 means what? This 10 belongs to this int I, let's say first method called it saw. Then this again sees that 10 of int, so this will go to here. So this will, this will this will get, let's say this will move to int I, and then what will happen here, the since in this method signature int is not present, so it will automatically promote this to float. So what will happen, so this will go to float here, so this will match to this as well, and in the second case what will happen, this will promote it to float, and this will be remain the this will remain same as int. So that is why it is saying that reference to m1 is ambiguous here, that it is this one is, for the first case, this is being this second argument is being automatically promoted, and for the first case, when it tries to match, this is being automatically promoted. So this argument is being automatically, so that is why it will give you a reference to this is ambiguous. So next is what, 10 t dot m1 of 10 point f. So what is this, since there is no float argument, and after promoting as well, there will be nothing like after promoting float to double, there is nothing, no method with the double arguments. So this will give you a compile time error. Okay, cannot find symbol, that is method m1 of float comma float. That is all. I hope this loophole was also clear to you. So what is the case 5? In case 5 we have class test public void m1 int arg. So in general method, public void m1 int triple dot int dot dot dot, what is this, this is basically an where argument type. This is from Java version 5, I think so. Yeah, 3, yeah, Java version 5, 8, I don't remember exactly. We have a concept of where you can pass variable number of arguments inside the method call stack. Okay, so this is where arg method. Let's see what happens now. Test t is equal to new test t dot m1. So of nothing. So what this will print? This will print where arg. So in why I'll tell you. Then this will print t dot m1 of 10 comma 20. So variable argument as well, because we can pass, this belongs to the variable argument category, we can pass any number of what we say the arguments to this method of m1. So t dot m1 of 10, this will go to general method. Why? Because we have only one argument. So while resolving while resolving, basically compiler, while resolving overloaded method, it will give the first priority to the where argument type. Okay, then sorry, then general argument will be given the priority after where argument type has been executed. Or basically it says that in general where arg will get the least priority, that is no method matched, then only where arg will get the chance. It is exactly same as default inside switch case. Okay, so this can be set to as that, let's say in switch case we have multiple, in switch statement we have multiple cases. If neither of those matches, then default will be executed, same as that. If nothing matches with this reference call, so what will happen, it will straightforward see if there is a vararg method, so it will forward it to vararg. So that is what. Okay, so this can also be asked, but in the interviews. Okay, that is but not much important, but this can be asked. So next case is, let's see, we have a class animal, we have a class monkey extends animal. Okay, class parent, class child extends parent, let's say, for just. So class test public void m1 and m1 animal a version. Okay, this is of type animal, accepting the argument type of animal, sopln and animal version. Okay, public void m1 again, then this is has a different type, that is of monkey. So this is of type, this accepts argument type of monkey type class. Okay, so sopln monkey version. So now test t is equal to new test animal a is equal to new animal. We have created the object of animal class. So t dot m1 of a. So t dot m1 of a, if we pass animal type argument, so what will be the output? Animal version, because animal type argument is with reference to exact match we'll get, that is of animal version. Now we create an object of monkey class child class, and we call t dot m1 of m. So since this is of monkey type, so this will be straightforwardly called, this will print, because the m1 is type of, the argument passed is of type monkey type. So we'll get monkey version. Let's say animal a, so parent reference and child object. Here comes the picture we saw in inheritance. Parent reference and child object. Now t dot m1 of a, this will give you animal version. Why? Let's understand. So in overloading, method resolution always takes care by in method sorry always takes care by compiler based on reference type. In overloading, runtime object won't play any role. Okay, so in that is what we studied in the starting of the video, that in overloading, method resolution always takes care by reference type. So what is the reference type? It is of animal type. A is of animal type. So which version? So what which class version will be executed? Animal class version will be executed. So that is why it is giving you animal version. Okay, so this is, I think, yeah, this is all about overloading. So in the next lecture we'll study about overriding. We have this, since this will be very long, this is very long since it contains overall the PDF. So I'll make another video around this. So I hope the session was quite informative. And next let's meet in the next lecture studying about overriding basically. Thank you.